Hello, everyone, and welcome to my video series, Chem in 10, where I'll review important concepts in chemical informatics in 10 minutes or less, give or take a few minutes. My name is Kimberly Dees, and I'm a chemical and health informaticist living and working in the Metro DC area. I'm also a data instructor and mentor and a PhD candidate in healthcare informatics at Rutgers University. So with that introduction, let's get started. This tutorial will be on extracting chemical data in the form of a JSON file using Python in a Jupyter notebook. We'll be working with the chemical substance called antipyrine and will extract its IUPAC name, common name, molecular weight, molecular formula, and SMILE string, which represents the data. The database we'll retrieve the JSON file from is GSRS, a substance database curated by NCATS, a division of the NIH. Links to this website, the presentation, and Jupyter Notebook will all be available in my Chem in 10 repository of my GitHub site. Now, before we get into coding, let's review a little bit about JSON files. JSON files are lightweight data interchangeable formats which contain or employ key value pairs which represent chemical data. They are also somewhat human readable. We use JSON files in chemical informatics to represent chemical structure information, reactions, molecular weights, and other chemical data. There are many benefits to using JSON files in cheminformatics, most notably that they are interchangeable, but also that they are compatible with numerous programming languages. They are also ideal for web-based chemical informatics tools and facilitate the seamless sharing of data and data integration. Now with that, we're going to go to the internet and we're going to look at our JSON viewer, which will allow us to view our JSON file. We're going to go to the GSRS website and we're also going to go to our Jupyter Notebook. So I mentioned that we're going to be extracting our JSON file from a website called GSRS, and that stands for the Global Substance Registry System. This data is maintained by the National Center for the Advancement of Translational Sciences, or NCATS, which is a division of the NIH. So the substance that we're going to be looking for is called antipyrine. When you go to GSRS, you enter in your substance into the search menu, you end up with a face card which has the following basic information: names, codes, molecular weight, etc. We're going to click on the name, and from that we have some other additional information about this substance, including its chemical structure, chemical moieties, other names, coded classifications, etc. Code identifiers, which include things like CAS number. Now, in the first top face portion of this website, you will see a downward arrow, and if you click on that arrow, you'll be able to download the JSON file. Must make sure I'm in the right section. So if you, as you just saw, if I click on the downward arrow on the chemical structure section, I'll end up with mole file, which we're going to talk a little bit about in a future video. But for the purpose of this video, we are looking at the JSON file. So we're going to click the downward arrow in the first face card on the substance, and we end up with downloading a JSON file. Now, I've already gone through and done that. So next we're going to go to our JSON viewer website. Again, a link for that will be provided in my GitHub site. And what we're going to do is we're going to copy and paste our downloaded JSON file into this viewer as a text. And then it's going to organize the data that's in the JSON file into a more readable format. So this is supposed to be human readable. I think that's debatable. At any rate, when we click on viewer, it gives us what we see are a list of nested dictionaries and lists which contain the substance information in this particular JSON file. So I mentioned before that we're going to be looking for the IUPAC name, the substance name, the molecular weight, the molecular formula, and the SMILE string. So you can see different sections of this dictionary. This list actually contains names. So within the JSON dictionary, the first level, we see a set of lists, which contains multiple dictionaries. So within these dictionary names, I've already gone through this. So I know that the first index 0 dictionary contains our IUPAC name, etc. So take some time on your own to look through that information. So now we're going to go over to our coding section where we're going to import this JSON file. We've identified the sections that have the information that we need. So I mentioned that names contains the names information, which makes sense. The other information is contained in a section of the file called structures. And for whatever reason, I'm going to be able to see it right now. Where is it? Here we go. Structure. actually contains the molecular formula, molecular weight, and the SMILE string. So we'll see more about that once we go over to our JSON file. All right, so let's go through the process of importing this JSON file and extracting the data that we need from it. So to start, we're going to use the module JSON. And we do that by importing JSON. And then we run that. And what we've done is imported the module, which will allow us to read in our JSON file and extract the specific information. So the code that we're going to use to read in our file is the following. So I'll go through a little bit about what we're doing here. The open function is used to open the file name. And I would suggest that when you download your JSON files, you name them according to the substance. In this particular case, it's antipyrine. So that would be called antipyrine.json. And the with statement allows us to ensure the file is properly closed after we extract the information. We've also created a variable called data, which is going to contain the information that was from the JSON file. So the next thing we want to do is, after we've assigned the JSON file information into the variable data, we want to take a look at that to make sure that it looks like it did when we looked at it in the JSON viewer. So we run that and we can see that it does in fact look like the information we saw in the viewer. Okay, so I mentioned before that the sections of the JSON file, which contains the molecular weight, the SMILES, and the molecular formula, are in the structured dictionary, which recall was a nested list of key value pairs that make up the JSON file for antipyrine. So what I've done here is I've imported a picture, an image of what that should look like. So this is a structured dictionary, and this is the information that contains what we're looking for. So the key here would be SMILES, and the value would be the SMILES string. Here, the key would be formula, and the value would be C11H12N2O, etc. So our next step is going to be to create a variable that will allow us to extract the specific information from that particular key value pair. Yeah. So I'm going to call this next variable data1, and I'm going to set data1 equal to the structure dictionary, which is contained within the JSON file. And then we're going to take a look at the output of that to make sure that it contains information that it should. So as we can see, the structure section contains mole, files, SMILES, etc. And we call that variable data1. And we can see here that the key value pairs map to the image that came from the JSON online viewer. So now our next step is going to be to extract the specific information, the SMILES string, the molecular formula, and the molecular weight from data1, which is the variable which represents the structure dictionary within the JSON file. And the way we're going to do that is we're going to create 3 different variables: SMILES, MF for molecular formula, and MW for molecular weight. We're going to set that equal to data1, which was the name of the data that contains the information that we're looking for, and we're going to specify the keys which will ultimately print out the values that we're looking for. So the keys that represent SMILES data is called SMILES. Let's just confirm that. The key that has molecular formula data is called formula, etc. So those are all correct. So our next step is going to be to print the output of those variables, SMILES, molecular weight, and molecular formula, using an F string or a formatted literal string, to print our SMILES variable data, our formula variable data, and our molecular weight variable data. And when we do that and run the code, we end up with SMILES, formula, and molecular weight. Now, the next step, remember, in this exercise was to extract the common name and the IUPAC name. Now, you may remember that this is a little different than what we did before, whereas this is a little more straightforward. You remember that the name information that we're looking for was contained within another set of dictionaries, or a nested set of dictionaries. So we're going to initially follow the similar step that we did before, where we created a variable called data1, but in this case, we're going to call it data2, and we're going to always use different variable names in case we have to go back to our original data set. So in this case, we're calling it data2. We're going to extract the names dictionary, which contains the information about the names of this particular substance. So we run that, and then we check to make sure that the data, or that the dictionary that we extracted actually contains the information that we are looking for, and we can see the name, common name antipyrine. That was located in dictionary, I thought that was located in dictionary 2, but I guess we'll find out when we go to do our additional extraction. So here we're going to extract the common name and the IUPAC name. So this is an image of the JSON file in the online JSON viewer. And remember I said that it was nested. So we have the list names, but then within that list names, we have dictionaries labeled from 0 to whatever number is the highest. It contains the different names of this particular substance. In this case, this contains the IUPAC name. So our 0 dictionary contains the IUPAC name. Now we need to look for the common name. So again, this is an image from our JSON viewer, and we can see that the 1 dictionary contains our common name. So our 0 dictionary contains the IUPAC name. The 1 dictionary within the list names contains the common name. So the code for this will be a little different than what we did before. So we have our data, which is called, our dictionary, which is called data 2. And what we're going to do is we're going to create 2 different initial variables called first dictionary and second dictionary. So our first dictionary is going to index dictionary 0, which contained our IUPAC name. We're going to call that first dictionary. Our second dictionary is going to index dictionary 1, which contains our common name. We're going to call that second dictionary. Then now finally, in order to extract the key value pair, we're going to call it common name. We're going to index that second dictionary variable, and we're going to look for the key name, and the value with name is the IUPAC name. And then we're going to do the same thing to get the IUPAC name. I'm sorry, right. Okay, let me start over. So the common name is contained in the second dictionary, which is 1. So second dictionary index 1. So second dictionary name value, name has our common name. And then the first dictionary, which is 0, index at 0, here, the key is name and the value is the IUPAC name. So hopefully that's not too confusing. I cleared that up. All right, so we run that. And now what we want to do is to print all of our output. Let's print our initial output. So let's print our common name and our IUPAC name to make sure that we actually have what we think we should have. So we're just going to use a basic print statement in Python. And so we end up with antipyrine, which is our common name. We end up with 2,3-dimethyl, what it says, which is our IUPAC name. And so now we want to print all of our extracted data elements together. Now that we've extracted all the data elements we were looking for, the common name, the IUPAC name, the molecular weight, the molecular formula, and the SMILE string, now we're going to print all of those data elements together. And we're going to do that just as we did earlier using an F string. Here's the code for that. We'll print that out. And what we end up with is our chemical name, antipyrine, IUPAC name, SMILE string, formula, and molecular weight. That's going to end today's lecture in JSON files used in chemical informatics. If you found this video helpful, please be sure to follow me for more videos in the chemical informatics field. Thank you once again. I'm Kimberly Dees, Chemical and Health Informaticist, and I will see you in the next video.